All right, we are looking at the mid-chapter 4.1 to 4.5 review. All right, the first couple problems perform the indicated operation. I might skip a few problems here and there if they're exactly like the one below it. So let's just look at this one. We're going to just combine like terms on these problems. So all the c squareds we're going to add together. We're going to add together the c's, and then we're going to add together the constants. So we get, for number 1, 4c squared plus negative c squared. 4c squared plus negative c squared is 3c squared. And negative 6c plus 3c is negative 3c. And then positive 2 plus positive 5 gives us plus 7. And that's our final answer. Now with the minus, it's important that we remember that we're subtracting all of this. So I like to distribute it, make it positive, and make that negative 6x, positive 7, and positive 5. And now I've taken care of that negative, and I can just add what I've got. So we have 4x plus, let's find our like terms. They're all scrambled here. 6x squared and negative 6x squared. Well, that's 0x squared. And then we have, 4x and plus 7x. So that gives us 4 plus 7, 11x. And then negative 3, negative 3 plus 5 gives us plus 2. Number 3 is multiplication. I like vertical multiplication. 2n squared minus n plus 5 times 3n minus 4. There's lots of ways to do this. You can use distributive property, multiply the 3n times everything. You can use the generic box, 3n minus 4, and then 2n squared minus n plus 5. Do it that way. I prefer the vertical multiplication. It's how you were taught to multiply in elementary school, so it kind of follows. So we're going to multiply the negative 4 times the 5, and I get negative 20. Negative 4 times negative n is positive 4n, and negative 4 times 2n squared is negative 8n squared. Then we have 3n times 5. 15n. I make sure I keep my variables and like terms lined up. 3n times negative n gives me negative 3n squared. And then lastly, 3n times 2n squared gives me a 6n cubed. And now I'll line up and add up my like terms. 6n cubed minus 11n squared plus 19n minus 20. And you'd get the same thing if you did it with the box over here. And I'll let you do your own way. And the last one, 4y plus 3 cubed. That means 4y plus 3 times 4y plus 3 times 4y plus 3. And you got to multiply that all out. You can use Pascal's triangle if you like. I'm going to multiply this one the long way, and then we'll have a Pascal's triangle later on. So 4y plus 3 times 4y plus 3. We get 3 times 3 is 9. 3 times 4y is plus 12y. And 4y times 3 gives me plus 12y. And then 4y times 4y is 16y squared. So we have 16y squared plus 24y plus 9. Now I need to multiply by 4y plus 3 again. 3 times 9 is 27. 3 times 24y is 72y. 3 times 16 is 48y squared. 4 times 9 is 4y times 9, 36y. 4y times 24y is 96y squared. And 4y times 16y squared is 64y cubed. And then we'll add up our like terms here. We have 64y cubed plus that's 14, 144 y squared plus 108y plus 27. Next we have evaluate, and we're going to evaluate these with synthetic substitution because it's so much faster and easier. With synthetic substitution, I'm going to use the exact number I'm given. I only change it when I'm given a factor, x plus 2 or x plus 3. So x is equal to -3, that's what I'm going to plug in. My coefficients are -1. It's missing an x to the 5th, so I'm going to put a 0, 14, there's 8x cubed, it's missing a y squared, so another 0, 50, and -5. And with synthetic substitution, my answer is what I get here. All right, so -1, bring it down. Multiply, -1, -1, -1 times -3 gives me 3. Then we have add 3. Multiply 3 times -3. -9. Add 5. 5 times -3. Multiplying by the number in the box, -15. Add -7. -7 times -3, positive 21. Add to get 21. 21 times -3 is -63. Add to get -13. -13 times -3 is -39. Positive 39. And -5 plus 39 is 34. Positive 34. So h of -3, the function h when I plug in -3, equals 34. All right, let's do number 6. We're going to plug in positive 4. 2, 1, -16, -50, and 2. We don't have any missing terms, so we don't need to add in any zeros. Bring down the 2. 2 times 4 is 8. 1 plus 8 is 9. 9 times 4 is positive 36. -16 plus 36 is 20. 20 times 4 is 80. -50 plus 80 is 30. 30 times 4 is 120, and 120 plus 2 is 122. So F of 4 equals 122. And you can do this by plugging them in and doing 4 to the 4th power times 2, but it takes so much more time, and you're not going to have a calculator tomorrow. Number 7, using Pascal's triangle to expand. So Pascal's triangle starts with a 1. That's our 0th power. And then 1, 1 is our first power. A plus b to the first power. And this is a plus b to the 0. Oops. 0 is the exponent there. Because anything to the 0 power is 1. And then it's 1. 1 plus 1 is 2. And then 1. Then 1 plus 2 is 3. 2 plus 1 is 3. 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then a 1, and then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 10, and, oops, that's not right, 4 plus 1 is 5, and then 1. So these are the coefficients we're going to use for a plus b to the 5th power. So I'm going to write them out. 1, 5, 10, 10, 5, and 1. So my first term is 2x. So I'm going to start with, let's do this in a different color, 2x to the 5th. And in the next term, it's going to be 2x to the 4th. And the next one is going to be 2x cubed. And the next one's 2x squared. And then 2x to the first power. And then 2x to the 0, which is 1. We're not going to write it down. And then my next one is going to be the 1, the -1. And it's going to start on the other end. It's going to start out here, -1 to the 5th, -1 to the 4th, -1 cubed, -1 squared, -1, and -1 to the 0, which is positive 1. Then I have to do my order of operations to multiply out each term. 2x to the 5th, 2 to the 5th is 32, x to the 5th. 2 to the 4th is 16. 16 times 5 is 80, negative 80 x to the 4th. Then 2 cubed is 8. Negative 1 squared is positive 1. And 10 times 8 times positive 1 would be plus 80x cubed. And then 2 squared is 4. 4 times 10 is 40. Negative 1 cubed is negative 1, so negative 40x squared. And then negative 1 to the 4th power is positive 1 times 2 times 5 is plus 10x. And negative 1 to the 5th is negative 1. And that's my final answer. All right, we're looking at some long division here. So I have 2x minus 3 goes into 4x squared minus 2x plus 6. So the first thing I'm going to do is I'm going to do 4x squared minus 2x. So 4x squared, I'm sorry, not minus, divided by 2x. 4x squared divided by 2x is 2x. And I'm going to put that on top of the 2x. And I'm going to multiply 2x times the 2x minus 3. Think about if you were dividing 12 into 396. You would do 12 goes into 39. 12 goes into 39 3 times. And then you would multiply. 3 times 12 is 36. So 2x times 2x minus 3 is 4x squared minus 6x. And then if you think back again, we subtract. So here we need to subtract, but when I subtract the whole thing, I need to make sure I'm subtracting that negative. So I like to change the signs to remind myself of that. And so my 4x squared is 0. And then I get let's write this in black. 4x plus 6, bring it down. Now I'm dividing 4x by 2x. And 4x divided by 2x is 2, so plus 2. Then I'm going to multiply 2 times 2x minus 3. So we get 4x minus 6. And then we're subtracting, so it changes the minus to plus again. And we get 12. So my answer is 2x plus 2, remainder 12. Remainder 12, or we really like it this way better, 2x plus 2 plus 12 over what I divided by 2x minus 3. So that's our preferred answer there. Let's move this stuff out of the way. Well, we'll just make a new page for this. Okay, so now we're going to divide x squared minus 1 into 2x to the 4th minus x cubed plus x squared plus x minus 5. So the first thing we're going to do the 2x to the 4th, the first term, divided by the first term, x squared, which is 2x squared. And I'm going to put it on top of my 2x squared. And then I'm going to multiply 2x squared times the x squared minus 1. So we get 2x to the 4th minus 2x squared. Well, I don't have an x cubed term, so I need to put the minus 2x squared under the x squared so I don't end up adding the wrong terms together. Then we're going to subtract, and we get negative x cubed, because that's 0, plus 3x squared, and we're going to bring down the plus x. And you can even just like bring the whole thing down too if you want. If we don't need it, we won't use it. And now we're going to divide negative x cubed by x squared, and that gives me negative x. And we're going to multiply negative x times the x squared minus 1, and that gives me negative x cubed plus x. Then we're going to subtract, so that's going to change those, and we get 3x squared plus 0x minus 5. And then now we're at 3x squared over x squared. That's what we're dividing. And that gives us 3. And then we're going to multiply the 3 times the x squared minus 1. So we get 3x squared minus 3. Then we subtract, and we end up with negative 2. So we have remainder negative 2, or our proper answer, 2x squared minus x plus 3 plus negative 2 over x squared minus 1. Now synthetic division. Synthetic division works when you have no coefficient and an exponent of 1. So we have y cubed. When it's y plus 2, we're really solving that to say y is equal to negative 2. I don't know how I got a 6 out of that. And that's what we're using for synthetic division. So we're going to put negative 2 here. And our coefficients are 1, negative 1. We have a 0y, so 0 and negative 6. It's really important you don't leave out those zeros on synthetic division. So we're going to bring it down. 1, that's not good. 1 times negative 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 3 times negative 2 is negative 6. Positive 6. Bring down the 6. 6 times negative 2 is negative 12. And we get negative 18. So this is our remainder. This is our constant. This is our x. And this is x squared. It should always be 1 degree lower if we're dividing by y. Because we're dividing, essentially, we're dividing y cubed divided by y. So our answer should start with, these should be y's, not x's. It's a habit. 1y squared minus 3x plus 6. So y squared minus 3x plus 6 plus negative 18 over y plus 2, or remainder 18. And number 11, we're going to put in negative 1. I have 4, negative 3, 2, and 0. I even need to add that constant on the end. So we'll bring it down. 4 times negative 1 is negative 4. Negative 7, 7. 2 plus 7 is 9. 9 times negative 1 is negative 9. 0 plus negative 9 is negative 9. So again, remainder, constant, then there's our p and our p squared. So 4p squared minus 7p plus 9 plus negative 9 over p plus 1. Factoring. Okay, so we have our sum and difference of cubes. A cubed plus b cubed is a plus b. A squared minus ab plus b squared. And a cubed minus b cubed is a minus b. A squared plus ab plus b squared. You have to have those memorized. And you have to recognize your perfect cubes. 1, 8, 27, 64, 125, 216, that's 6, 343, 512, 729, and 1,000. You're expected to know those and recognize cubic, cubic, cubic. That's the only time you can use the perfect or the cube pattern is when you have a sum or difference of cubes. And you should be recognizing your perfect squares as well. So for number 12, if my a is 3h because 3 cubed is 27 and my b is 1. I'm going to plug it into the difference pattern because I'm subtracting. So it's 3h minus 1 times 3h squared, the 3h times 3h, plus 3h times b, which is 1, plus 1 squared. So that's 3h minus 1, 9h squared, plus 3h plus 1. This is 12. Number 13, 6x squared minus, 6x to the 6th minus 6x squared. First, I always look for common factors first, so my common factor is 6x squared, and we get x to the 4th minus 1. And I need to recognize 1 is a perfect square as well, and x to the 4th is a perfect square. So this is a difference of squares pattern, x squared plus 1, x squared minus 1. And x squared plus 1 is the one we could factor into imaginary numbers, x plus I times x minus I. This is sum of squares. And the difference of squares again, x plus 1, x minus 1. 14. When we have 4 terms, we should think factor by grouping. So we have x cubed plus 6x squared. We're going to group that together. Plus negative, we're going to bring the negative inside, negative 4x minus 24. We can factor out an x squared. So we get x squared times x plus 6. And I can factor out a negative 4 times x plus 6. Now, what I'm going to factor out is the common factor of x plus 6 times what's left, x squared minus 4. And if I check this and multiply it at this point, I would get what I started with. But this can be factored more. X plus 6, we have a difference of squares. X squared is x, or x squared minus 4 is x plus 2, x minus 2. And number 15, we have 2a to the 4th minus a squared minus 6. And this is a quadratic in, it's in quadratic form. So the only way to get 2a to the 4th is 2a squared and a squared. And then 6 is 6 times 1 or 3 times 2. So if I put my 2 here and my 3 here, I get 6a squared and 2a squared, which is not going to give me negative 1. So we're going to rethink that. How about if I put my 3 here and my 2 here? That gives me 4a squared and 3a squared. And if I need a negative a squared, I'm going to make the 4 negative and the 3 positive. So my answer is going to be 2a squared plus 3 times a squared minus 2. And those are neither difference of squares or sum of squares, so they cannot be factored anymore. Sketch the graph and describe the end behavior. So for number 16, let's see, let's look at this little graph here. We have positive and negative when we have even and we have odd. Positive evens are all going to look in the end like a positive parabola, and negative evens are going to look like a negative parabola. They always end positive, and negative. Evens, they're in the same direction. Odd is going to end positive, so it's going to look more like this, and it might have more going on in the middle. So odd positive is going up, and odd negative goes down. So there's our end behavior. We're looking at positive being the leading coefficient, and even or odd the degree, which is the highest exponent. When it's in factored form, we're looking to add our exponents together. X squared and x to the 5th gives us the 7th degree, and the negative. And then my zeros are 0 and 3. But 0 is a double, so it's going to bounce. And 3 is a 5th, 5 of them, which does that little inflection point, which I just call snaking through it. So we'll have our points at 0. Let's do this in a different color. And 3. And it's negative, so it's going to start up here and end down here. So the double roots bounce off of it, so it starts in my up, it bounces off my 0, my double root, and it does a snake motion through that triple 5th root, and then it goes down from there. Number 17, I have x to the 1 power, x to the 1 power, x to the 1 power, so that's going to be x cubed. That's my degree. And the leading coefficient is 1, so it's positive. So it's going to start down low and end up high. Now each of these roots, my zeros are 1, -2, and -5. These are my zeros. And so they're just going to pass right through the axis. So I start down here, and I'm going to end up here. So I'm going to go through -5, turn around and go through -2, and turn around and go through +1. And number 18, I have 2 plus 4, that gives me a degree of 6, and the 5 is positive, so it's positive. My zeros are 2 and -7, and this is a double, and this is a quadruple, but they act the same. They're going to bounce off both. So we have +2, -7, and if it's positive even, it's going to start up high, bounce, bounce, and end up high. Given one of the zeros, find the other zeros. So if I know that the 0 is 3, I'm going to use synthetic division, synthetic substitution, to get the rest, or to find out what the other zeros are. So I'm really I'm dividing, and when I'm dividing, factoring is a way of dividing. So what I'm getting is what the next factor is when I plug that in. So let's see, 1, bring it down, 1 times 3 is 3, -5 plus 3 is -2, -2 times 3 is -6, 5 plus -6 is -1, -1 times 3 is -3, and I got 0. This is a good thing. It tells me it's a 0. So if I don't get 0, I did something wrong there. And my leftover polynomial, what I got when I divided, is x squared minus 2x minus 1. Okay, so now, this looks a lot like one that we normally factor, but it's not actually. That would be x squared minus 2x plus 1. So we may have to do a little completing the square on this one to find the other zeros. X squared minus 2x. I'm going to add the 1 to the other side, equals 1. And we're going to take the b term, divide it by 2, and square it. So -1 squared is 1. And then we're going to add it to both sides, plus 1, plus 1. And I get x squared. Oh, wait, no, I want to factor that. So x minus 1 squared equals 2. And then we're going to take the square root of both sides, plus or minus the square root. That's x minus 1 equals plus or minus 2, and add 1, plus or minus the square root of 2. And I get x equals 1 plus or minus square root 2. So my zeros are 3 and 1 plus or minus the square root of 2. Okay, so now determine if the factor is a 0. So we're going to use synthetic division, and if we get a 0 like we did on this one, then we know that that factor, or that it is a factor, and that 3 is a 0. So we'll plug in 3, because we'll set that equal to 0, and x equals 3. And we have 1, x to the 4th. Those are the coefficients that I'm plugging in here. So 1, 4, 5, 4, and 4. So 1, 3, 7. 7 times 3 is 21. 5 plus 21 is 26. 26 times 3 is 60 plus 18, 78. 4 plus 78 is, there's no negatives in there. So 4 plus 78 is 82, and 82 times 3 is 246. And when I add that, I get 250, and this is not 0, so this is not a factor. So factor this polynomial, given this is a factor, so this should give me 0 when I do that. So I'm going to plug in -2. Again, my coefficients are 1, 4, 5, 4, and 4. 1, 4, 5, 4, 4. So it's 1, -2, 2, -4, 1, -2, 2, -4, and 0. And then what I have here is This is my remainder of 0. Here's my constant. So this is x squared, and x cubed. So x cubed plus 2x squared plus x plus 2. This is a factor. The first factor was x plus 2. Now I want to try to factor again. And if I can't factor more, then I would have to use my P and Q strategy like we did in later. But if I have 4 terms and it looks like I have a pattern here, it looks like I should be able to factor by grouping. So we're going to group those together. Plus x plus 2. And I factor out an x squared, and I get x plus 2. Plus, technically, I could factor out a 1 times x plus 2. Then I'll factor out my x plus 2. There it's those. And I'm left with x squared plus 1. And then let's bring that original x plus 2 factor down. So this is factored completely in the real numbers, and then the x squared plus 1 is a sum of squares, which factors to x plus I, x minus I, if I'm factoring into imaginaries. Number 22 says solve, so I'm going to add the 80 to the other side. X to the 4th minus 21x squared plus 80 equals 0. I'm looking for two numbers that multiply to 80 and add to negative 21, x squared and x squared. I get negative 16 and negative 5. That equals 0. This factors more, x plus 4, x minus 4, x squared minus 5. And then my x equals negative 4, positive 4. And x squared minus 5 equals 0. I can solve that by adding 5 to both sides. X squared equals 5, plus or minus the square root of 5. And there are my 4 solutions. If it says x to the 4th, if that's the highest exponent, I should have 4 solutions. And the last one's find the zeros. We're going to find it by factoring. So this is a is my 2x, b is 1. This is a cubic. So that's 2x minus 1 times 4x squared, because that's 2x squared, plus 2x times 1 is just 2x, plus 1. That equals 0. This is never... this is not factorable, ever. So that's going to have to use quadratic formula. 2x minus 1 equals 0. 2x equals 1. X is 1/2. And let's do negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. And that's negative 2 plus or minus the square root of 4 minus 16 over 8. Negative 2 plus or minus the square root of negative 12 over 8. 12 is 4 and 3, so that's 2i radical 3. So negative 2 plus or minus 2i radical 3 over 8, which is negative 1 plus or minus I radical 3 over 4. I just divided everything by 2. And then lastly, this is a difference. It's just a quadratic, x squared. What two numbers multiply to 8 and add to negative 6? Let's see, negative 4 and negative 2. And so I get x plus 2, x minus 2. X squared minus 2 equals 0. X equals negative 2, positive 2, and plus or minus square root of 2. You should be able to solve that one by yourself. But don't leave off your plus or minus. That's a big mistake. Remember, we need 4 answers.